Students, today we shall see the rationalization of the irrational numbers. Rationalization of the irrational numbers. So, before going to the problems, we will see the definition of the process of the rationalization. Rationalization means here, rationalization means it is the process. So, it is the process of multiplication of irrational number by another irrational number. So, rationalization means it is a process of multiplication of irrational number by another irrational number. So, that process is called as rationalization. So, to do this rationalization, we must know some key points we have to remember. So, first point is, so the product of two irrational numbers, the product of two irrational numbers is a rational number. Product of two rational numbers is a rational number, and each irrational number, so which is multiplied, is called as rationalizing factor. Rationalizing factor, and shortly we will write it as RF. RF means rationalizing factor. So next point we have to remember is rationalizing factor of a monomial. So already we have seen in the previous problems. So we have simplified the monomial irrational numbers, binomial irrational numbers. So for that, rationalizing factor of monomial is the same irrational number. So for the monomial irrational numbers, so the rationalizing factor is same irrational number. So whereas in case of rationalizing factor of binomial irrational number, the rationalizing factor of the binomial irrational number is the conjugate. Conjugate means so we have to change the sign of the given irrational number. Binomial irrational number. Just we have to change the sign. In case of plus, we will write minus. In case of minus, we will write plus. So it is a conjugate of a binomial irrational number. Now let us see the we will understand these concepts of rationalization by taking an example. So here in the example we have given that rationalize the denominator of 1 by root 2. So here we have to rationalize the denominator only 1 by root 2. So solution for this is, so if you observe the given problem, so it is 1 by root 2. Here we have to rationalize only the denominator. So therefore we have to write the rationalizing factor of the denominator. Rationalizing factor of the denominator. So if you observe the denominator of the program, so it is a monomial. It is a monomial irrational number. So according to these points, so the rationalizing factor should be the same because it is a monomial. So therefore, the rationalizing factor of RF means, already I have told here, RF means rationalizing factor. RF of root 2. Root 2 is a monomial. So therefore, the rationalizing factor of root 2 is the same root 2. You have to remember this. The rationalizing factor of the monomial is the same irrational number. So now we will simplify it. Write the problem as it is 1 by root 2. So we have to rationalize the denominator. Therefore, we are going to write the rationalizing factor of the denominator. So here it is root 2. The RF of root 2 is root 2 ahead. So multiply this root 2 to be both numerator and denominator. So 1 by root 2 is there. We'll multiply root 2 to the numerator, root 2 to the denominator, root 2 to the denominator. So if you multiply root 2 to the both numerator and denominator, so these two will get cancels. Our original value will not be changes. For this purpose, we have to multiply the rationalizing factor of the both numerator and the denominator. Now multiply this numerator and the denominator. So you will get 1 into root 2. So it will be equals root 2 by. So root 2 into root 2, it is root 2 whole square. Root 2 whole square, which will be equals, write the numerator as it is, root 2 by here 2 and root get cancels, equals it will be 2. So therefore, which is a rational number. Therefore, the answer is root 2 by 2. So here it is converted in this problem. So in problem it is an irrational number. So in the solution, that irrational number is converted to the rational number because we are rationalizing the denominator only. So this is how we rationalize the denominator of a monomial. Now students, we shall see the rationalizing the denominator by a binomial irrational number. Binomial irrational number. So now we shall see the next problem. So the next problem is, second one is rationalize the denominator of will take denominator of, next problem is 1 by 2 plus root 3. 2 plus root 3. 1 by 2 plus root 3. So if you observe the problem, so in the previous problem it is 1 by root 2. 1 by root 2. So here we have to rationalize the denominator. So therefore write the rationalizing factor RF of the denominator. So if you observe in this problem, see it is a binomial. It is a binomial. So because it is a combination of rational and irrational, or both are irrational. So here it is a binomial. So by the point, the rationalizing factor of the binomial is a conjugate of the given binomial. Is a conjugate of the binomial. So here we are going to use the word conjugate. We are going to use the word conjugate for binomial irrational numbers, not as a rationalizing factor. We will not write as a rationalizing factor for the binomial irrational numbers. For these binomial irrational numbers, we call the rationalizing factor as a conjugate. As a conjugate. For monomial, we call it as a rationalizing factor. So now we will write the problem. Solution is, the problem is 1 by 2 plus root 3. 2 plus root 3. So here we have to rationalize the denominator. Observe the problem. We have to rationalize the denominator only. Therefore, we have to write the rationalizing factor or the conjugate or the denominator only. So, for the monomial irrational numbers, it is called as a rationalizing factor, whereas in case of binomial irrational numbers, it is called as conjugate. So now we will write the conjugate of this. So conjugate of 2 plus root 2, sorry, 2 plus root 3 is so just we have to change the sign. What is the problem? Is 2 minus root 3. Conjugate of 2 plus root 3 is 2 minus root 3. Now, as in the previous problem, so we will multiply this 2 minus root 3 to the numerator and the denominator. It will become 1 by 2 plus root 3 into the conjugate is 2 minus root 3 by 2 minus root 3. So we have multiplied 2 minus root 3 to both the numerator and the denominator. So now multiply the numerator and the numerator to the numerator, denominator to the denominator. So it will become, so 1 into anything is the same. So 1 into 2 minus root 3 is 2 minus root 3 divided by. So this will be of the form a plus b into a minus b. It will be a plus b into a minus b. So already know that the formula or the identity a plus b into a minus b is a square minus b square. It will become 2 square minus root 3 whole square. 2 square minus root 3 whole square. Write the numerator as it is. It will become 2 minus root 3 by 2 square. 2 2s are, it is 4 minus, so square and square get cancels. It will be 3. So now simplify the denominator. So it will become 2 minus root 3 by 4 minus 3 is 1, which is equal to 2 minus root 3. So this is the answer of the given program. So I think students, we have understand how to rationalize the denominator. So now we will be see the exercise problems. So by doing this exercise problems, we will perfect in the rationalization of the irrational numbers. Okay. Students, now observe the problems of exercise 1.5. Rationalize the denominators of the following. First one is 1 by root 7. Second one is 1 by root 7 minus root 6. Third one is 1 by root 5 plus root 2. Fourth one is 1 by root 7 minus 2. Fifth one is 5 by root 3 minus root 5. Sixth one is 1 by 7 plus 3 root 2. So I will show two problems. So you have to complete that in your homework. Okay. So already you have studied how to rationalize a monomial irrational number. So therefore I will left this problem to yourself. So I will take up the second problem. Second one, fifth one, and the sixth one. The second problem is 1 by root 7 minus root 6. 1 by root 7 minus root 6. So if you observe the denominator of the given irrational number, so it is a binomial. So for this we have to write the rationalizing factor. That means we call this for the binomial number, irrational number, we call it as a conjugate. So conjugate of root 7 minus root 6 is observed here with the students. The conjugate or the rationalizing factor of the binomial is same, but we have to change the sign. So if it is plus, we have to write the minus in the conjugate. If it is minus, we will write plus for the conjugate. So therefore the conjugate of root 7 minus 6 is root 7 in place of minus write plus root 7 plus root 6. So I think you are clear about the writing the rationalizing factor of the given irrational numbers. For the monomials, write the same irrational number. For the binomials, we will call rationalizing factor as a conjugate. In writing the conjugate, write the same irrational numbers but change the signs. In place of minus, write a plus. So in place of plus, write minus. So therefore here the conjugate of denominator root 7 minus 6 is root 7 plus root 6. So now we will simplify. Write down the problem. 1 by root 7 minus root 6. 1 by root 7 minus root 6 into, so conjugate is root 7 plus root 6 divided by root 7 plus root 6. So multiply numerator to the numerator, denominator to the denominator. So we will get 1 into root 7 plus root 6. So it will remain as it is. For the denominator, it is of the form a minus b into a plus b. So a minus b into a plus b, we will write a square minus b square. So it will become root 7 whole square minus root 6 whole square. So in the denominator, we are going to use the identities a plus b into a minus b, or a minus b into a plus b, which is equal to a square minus b square. You are already studied in the previous classes. So numerator write as it is. So it will become root 7 plus root 6 by, so this square and root get cancelled, square and root get cancelled, so it will be 7 minus 6. 7 minus 6. Square and the root. Square and the root get cancelled. It will become root 7 plus root 6 by 7 minus 1 is 1. In the next step, so it will be root 7 plus root 6. This is the simplified form of the given problem. So now we will take another next problem. Students, next we will take 5 by root 3 minus root 5. So 5 by root 3 minus root 5. So once again, we are going to rationalize the denominator. So therefore, what is the conjugate of the denominator? Yes, the conjugate of root 3 minus root 5 is root 3 plus root 5. So now multiply this root 3 plus root 5 to the both numerator and the denominator. So next we will see 5 root 3 minus root 5 into multiply this root 3 plus root 5 to the numerator and the denominator. Root 3 minus root 5, 3 minus root 5. So now multiply numerator to the numerator. So it will be 5 into root 3 plus root 5, right, as it is. So for the denominator, again, here it is plus. So for the denominator, it is of the form a minus b into a plus b. It will become a square minus b square root 3 whole square minus root 5 whole square. So now if you observe the denominator, square and the root get cancelled, square and the root get cancelled. So write the numerator as it is. So the numerator will be 5 into root 3 plus root 5. Root 3 plus root 5. The denominator will be 3 minus 5. In denominator it will be 3 minus 5. So if you simplify, you will get, write the 5 as it is outside the bracket. 5 into root 3 plus root 5 by, if you subtract 5 from 3, 3 minus 5 is minus 2. Minus 2. Or we can write this as minus 5 by 2 minus 5 by 2 into root 3 plus root 5. So this is the simplified form of the given problem. Okay, students, I think you have understand how to simplify or how to rationalize the given irrational numbers by rationalizing the denominators. Now students, we will see the last problem. That is what problem is 1 by 7 plus 3 root 2. Now write the conjugate of 7 plus 3 root 2 is 7 minus 3 root 2. 7 minus 3 root 2. Now multiply this conjugate to the both numerator and denominator. It becomes 1 by 7 plus 3 root 2 into 7 minus 3 root 2 by 7 minus 3 root 2. So 1 by 7 plus 3 root 2 into 7 minus 3 root 2 by 7 minus 3 root 2. So multiply numerator to the numerator and denominator to the denominator. So it will become 1 into anything is the same. So it will be 7 minus 3 root 2. So now for the denominator, students, for multiplication of the denominator, you have to remember we are going to use the formula a plus b into a minus b. So therefore, so here it will be a square minus b square. So it will be a square, 7 square minus 3 root 2 whole square. 7 square minus 3 root 2 whole square. So now simplify the denominator. It will become 7 minus 3 root 2 by 7 square is 49. 7 square is 49. So now if you observe this second term, 3 root 2 whole square. Here we have to multiply both the 2 multiplier 3 2 times and root 2 times. So it will become 3 3s are. So it will become 3 3s are 9 into root 2 whole square. If you observe this problem carefully, so we have to multiply 3 root 2 2 times. 3 root 2 2 times. It will become 3 root 2 into 3 root 2. So it will be 3 3s are 9 into root 2 whole square. So now root and square get cancelled. In the same way, write the numerator as it is 7 minus 3 root 2 by 49 minus 9 root and square it cancels 9 into 2. So it will be equal to, write this numerator as it is 7 minus 3 root 2 by 49 minus 9 twos are 18. So simplify the denominator. 7 minus, write the numerator as it is 7 minus 3 root 2 by 49 minus 18. So it will become 49 minus 18. So 9 minus 8 is 1, 4 minus 1 is 3. So it will be 31. The answer is 7 minus 3 root 2 by 31. So the denominator is a rational number. So we get the denominator here, it is rational number. So in the problem, it is an irrational number. So therefore this process is called as rationalization and rationalizing the denominator. So students, I think you have perfect in the rationalization of the irrational numbers. So there are some remaining two problems are there. You have to do it in your home itself. Now students, we will see the next part of this chapter, number system, laws of exponents for real numbers. Laws of exponents for real numbers. So you have already, students, you have already studied the laws of indices or laws of exponents in the previous classes. So you will recall them. The first law is a to the power of m into a to the power of n equals a to the power of m plus n. The first law of indices is So a to the power of m into a to the power of n equals a to the power of m plus n. So second law is a to the power of m by a to the power of n equals a to the power of m minus n. Here the condition is m should be greater than n. M should be greater than n. So third one is a to the power of m to the power of n equals a to the power of m into n. A to the power of m to the power of n equals a to the power of m n. So and the next law is a to the power, fourth one is ab to the power of m equals a to the power of m into b to the power of m. So these are the four laws we have studied in the previous classes. So a to the power of m into a to the power of n equals a to the power of m plus n. So a to the power of m by a to the power of n equals a to the power of m minus n. So when m greater than n, this condition I have taken here. So there is another condition is there. So if m greater than m, then it will be a to the power of 1 by a to the power of m minus m. So third one is a to the power of m to the power of m equals a to the power of m. Fourth law is ab to the power of m equals a to the power of m into b to the power of m. So that means if the base is same, so here also in this exponents we call this as a base, this as an exponent. So if the bases are same, then the product should be, we have to add the exponents. So the another one is there, so it will help for the problem. So 1 by a to the power of n, or you can write a to the power of m. It becomes a to the power of minus n. So we can change these formulas, right side to the left side to the right side. That means, so if they have given the problems as a left side, we will simplify to the right side. If they have given to the right side of the problem, we will write it as a left side. So now we shall see the problems. Students, in the exercise 1.6, so there is a first main. The first main, find the value of 64 to the power of r. Second one is 125 to the power of 1 by 3. Third one is 52 to the power of 1 by 5. So we will see the first problem. So now for the first problem, so here this is the base, 64 is the base. So write the factors of the given base by prime factorization method. So if you take the factors of 64, you will get, so 2 3s are 6, 2 2s are 4. So again 2 1s are 2, 1 carry 4 is there, 2 6s are 2 8s are 2 4s are 2 2s are 2 2s are. So this type of factorization you have done in the previous classes. This type of factorization so you have done in the previous classes. Therefore, so this can be written as, so therefore 64 to the power of r, so it can be written as, so how many 2's are there? How many 2's are there? written as 2 to the power of 6. So 64 can be written as 2 to the power of 6. The index 1 by 2 is written as it is. The index 1 by 2 is written as it is. Now, by using the laws of indices, we are going to simplify this. Write the base as it is. So, by using the formula or third law, a to the power of m to the power of n equals a to the power of mn. So, similarly, 2 to the power of 6 into 1 by 2. 2 to the power of 6 into 1 by 2. Now simplify this. 2 ones are 2 3s are. So it will becomes 2 to the power of 3 ones are 3. So that means 2 should be multiplied 3 times. We will get 2 into 2 into 2. It becomes 2 2s are 4 4 2s are 8. So therefore the simplified form of 64 to the power of 1 by 2 is 8. Now we will see the second problem. So it is 125 to the power of 1 by 3. So write the factors of 125 by factorization method. So if you write factors of 125, 5 2s are 10, 2 carry 25, 5 5s are 25. So once again 5 5s are 25. So therefore, the problem is written as, therefore 125 to the power of 1 by 3 is written as 5 2 1 2 3. So there are 3 5s are there. 5 2 to the power of 1 by 3. So once again here we are going to use the third law. A to the power of m to the power of n equals a to the power of mn. It will becomes 5 to the power of 3 into 1 by 3. So 3 ones are 3. So it will becomes 5 to the power of 1. So the answer is 5. Students, now you should try the third problem, 32 to the power of 1 by 5. So its factor is 2. So write down the factors of 32 by prime factorization method, that is 2 divided by 2. You will get the factors and then simplify it. Now students, we will simplify the next main. Next main is second main. Find the value of 9 to the power of 3 by 2, 32 to the power of 2 by 5, 125 to the power of minus 1 by 3. So now we will take the factors, prime factors of 9, 3 3s are. So therefore, solution for this problem is 9, therefore 9 to the power of 3 by 2 equals, so this the factors of 3 square, 3 square to the power of 3 by 2, 3 square to the power of 3 by 2, so it becomes a to the power of m to the power of n, it becomes 3 square into 3 by 2. So here 2 ones are to get cancels. So in the numerator it will be 3 ones are 3 cube, which will be equals 3 into 3 into 3. Increase on 9 3s are 27. So the simplified form of the value of 9 to the power of 3 by 2 is 27. So now students, we will move on to the second problem. Now find the factors of 32. by trying factorization, 2 16s are 32, again 2 8s are 16, 2 4s are 8, 2 2s are 4. So write down the problem. Solution for that is 32 to the power of 2 by 5 equals 2 to the power of 1, 2, 3, 4, 5, 2 to the power of 5 to the power of 2 by 5. So this will be equals 2 to the power of 5 into 2 by 5. So 5 ones are 5. So it will become 2 ones are 2. 2 square equals 2 into 2. 2 should be multiplied 2 times. 2 is 4. So similarly, so here we have to find out the factors. So 5 is 10, 1 carry, 2 carry, 5 5 is 25. So again 5 5 is 25. So now write down the program. Solution for this is 125 to the power of minus 1 by 3 is written as 52 to the power of minus 1 by 3. So equals 52 into minus 1 by 3. 52 into here, you should have to observe the sign here. This minus is there. So in all the previous problems, sign is positive. So here it is 3 ones are 3. So 5 to the power of minus 1 into 1 it is minus 1. So therefore it is 5 to the power of minus 1. So by using this fifth loss of indices 1 by 8 to the power of n equals, so 8 to the power of minus n. So this is in the problem it is of the form a to the power of minus n. So therefore we have to convert this to the positive sign. It will becomes 1 by 5 to the power of 1, which is equals, so which will be equals 1 by 5. So 1 by, here it is 5 to the power of minus 1. By using this last law, a to the power of minus n can be written as 1 by a to the power of n as a positive number. So this 5 to the power of minus 1 is written as 1 by 5 to the power of 1. Write the numerator as this 5 into 1 is 5. So therefore the answer is 1 by 5. Now we shall see the next main. Now students, we will move on to the last main of this exercise. So simplify. First problem is 2 to the power of 2 by 3 into 2 to the power of 1 by 5. Second problem is 1 by 3 cube to the power of whole to the power of 7. So third one is 7 to the power of 1 by 2 into 8 to the power of 1 by 2. So again here we are going to use the same laws of indices. So for the first problem, now remember the first law. So here if you observe the problem, it is 2 to the power of 2 by 3 into 2 to the power of 1 by 5. So here the base are same. So therefore in this problem we are going to use the formula for the loss of indices a to the power of m into, so a to the power of n equals a to the power of m plus n. So by using this formula we are going to use that, simplify 2 to the power of 2 by 3 into 1 by, sorry, into 2 to the power of 1 by 5. So this can be written as 2 to the power of 2 by 3 plus 1 by 5. So here the bases are same, 2 is there. So if the bases are same, we are going to add the numerators. So therefore it will be written as, by using this formula, 2 to the power of 2 by 3 plus 1 by 5 will become 2 to the power of, now, so LCM of 3 and 5, both are prime factors, LCM is 50. 3 5s are 3 into 5, so it is 15. So 2 to the power of 15, simplify this fractions. So now divide the LCM by the denominator of the first fraction. So 3 5s are 50, 5 into 2, so it is 10 plus. So divide this LCM by the denominator of the second fraction. 5 3s are 15, 3 into 1, 3. So it will becomes 2 to the power of 10 plus 3, it is 13 by 15. So the answer is 2 to the power of 13 by 15. So it is the simplified form of the given problem. So coming to this problem, so here remember or recall the formula is of the form a to the power of m to the power of n equals a to the power of mn, a to the power of mn. So apply this to the given problem. 1 by 3 cube to the power of 7, we can written as 1 to the power of 7, 3 to the power of 3 into 7. So 1 7s are 7. Sorry, 1 7s are 1 should be multiplied 7 times. So it will be, the answer will be 1. So in the denominator, 7 is 3 to the power of 21. So this can be written as, again, if you take this to the numerator, it will become 3 to the power of minus 21. So 3 to the power of minus 21. So this is the answer. So now observe the third problem. For this, recall, so which is the formula or which is the loss of indices we are going to use is use here. Yes, it is a to the power of m to the power of, sorry, a to the power of m into b to the power of m equals a into b to the power of m. A into b to the power of m or n. So we are going to use this formula. So now 7 to the power of r into 8 to the power of r equals 7 into 8 to the power of 1 by 2. So which will be equals 7 8s are 56 to the power of r. 7 8s are 56. So 56 to the power of r. So that can be the result of the given problem or simplified form of the given problem. So I think students, you have understand this chapter, and you can go through the textbook and exercise problems and the videos. You have to understand clear about the chapter number system and work in your home, so you will become perfect in this chapter. Okay, so from this video this chapter will be completed. So in the next video we will see the another chapter. Okay.